into the topic of bonding, okay? And normally when we start bonding, we start with naming and writing compounds, right? Now today what we're going to look at naming and writing binary ionic compounds. So let's go. Okay, so our topic is bonding. Okay, and we're looking at naming. Okay, binary ionic compounds. All right, and we're also going to write them. Okay, so we'll kill two birds with one stone. All righty. Now, before we jump into the naming and the writing, we got to do a bit of background. We've done atomic structure. We've done periodic table, right? Now, the thing is, you might be wiping your brow and says, "Whoa, okay, got rid of those guys." But guess what? You haven't, because in the topic of bonding, right, we're gonna have to go back to our knowledge of atomic structure and the periodic table. So once again, I keep saying over and over, chemistry is foundational, right? So you cannot put aside, you cannot discard, you can't forget the previous stuff that you learned, right? So always review your notes of the previous topics because they help build and make a foundation for the other topics that are coming up. Okay, so in bonding, right? All right, what are we doing? We're mainly looking, right, how elements combine, okay? Now, we're talking combining chemically, right? And in order to combine, right, they have to interact with their valence, okay, electrons. When they interact with their valence electrons, they form bonds, right? Okay? Now, the thing is, we'll talk about different types of bonds, right? Now, today we're looking at ionic bonding. There's covalent bonding, there's metallic bonding, there's network solids, there's all those guys, right? But today we're keying in on ionic bonding. And in ionic bonding, guys, ionic bonding, okay, there is a transfer, okay, a transfer of electrons. Now let's do some recapping again. We had this in the previous videos, but let's just recap again. Remember our good friend sodium, right? Sodium is 11 protons. Okay, hopefully you guys can see that. Now we already did this already, but let's redo it again because it's important. It loses its valence electrons. Sodium is a typical metal, right? In group 1, it loses its valence electron at 1 valence electron, okay? To get a stable octet, it becomes 2-8, right? Still with 11 protons, okay? So we have 11 protons in both cases, but when you form the sodium ion Na+, all right, you're losing 1 electron, noble gas configuration, stability, right? But what happens in bonding, people? Bonding provides even more stability. So the electron that is lost by sodium, right, does not go into outer space, okay? Some other element gains it, okay? So let's look at chlorine. All right, another classic example. 2, 8, 7, right? With 17 protons. Alrighty? Now what does chlorine want to do? Chlorine is a typical non-metal in group 17, the halogen or halide group, right? So we know from experience, right? This guy, when it forms an ion, it's still going to have 17 protons, but its configuration is going to turn to 2, 8, 8. So what they can do, they can help each other out. He needs 1 more electron to get to a stable octet. He needs to lose an electron to get to a stable octet, right? So he loses this electron right here. This electron goes to the chlorine, right? Now we're going to form a what? We're going to form a Cl- ion, okay? So once again, ions are formed by loss of gain electrons. Positive ions formed by loss of electrons. Negative ions are formed by gain of electrons, right? Now this guy is positive, this guy is negative. This is going to happen, the A word, okay? And the A word is attraction, all right? So these guys, a positive and negative ion, will attract to each other and they will form NaCl, okay? Sodium chloride, table salt. Now the thing is, you're gonna have millions and millions and millions of these ions, right? Positive, negative stuck together in something called a crystal lattice, right? But in ionic compounds, we represent the simplest whole number ratio possible, right? So let's say you have, I don't know, 10 million sodiums and 10 million chlorides stuck together, right? The ratio is still 1 to 1, so we simply say NaCl, no problem. So our ionic compound formulas must reflect the simplest whole number ratio, always. Okay, so remember, keep it in our memories, okay? And for ionic compounds, it's called something called the formula unit, all right? Universally, it's called the empirical formula, right? Okay, but for ionic compounds, it's called the formula unit. So empirical formula universally, right? No problem. Ionic formula unit. It's good to know. Okay, so ionic compounds are formed how? By attraction between what? Ions. Just recapping real quick before we move on. Ions, okay? Positive and negative ions. They're formed by transfer electrons and attraction of the ions. So it's called an ionic bond. Ionic bonds make ionic compounds. So now we're ready to move on to look at how we write the formulas and how we name these guys. Okay, so let's draw a little smooth here. See this board right here. Okay, let me see. I think that's good. Okay, so here I have lithium, calcium, and aluminum, right? And over here I have fluorine, sulfur, phosphorus, and carbon. Alrighty? Let's put it back a bit. Okay. So what we do, guys, when you're doing the to write the formulas, all you have to do, folks, is something called the criss-cross method. So here we go. Right up here. Criss-cross. All you're doing, folks, you're switching the number of the charge. Okay, not the charge, just the number of the charge. For example, this guy right here is +1. That guy right there is -1, right? So here's the deal. You will have lithium, right, +1. You will have fluorine -1. Now the rules are very simple for this. The positive ion, right, which is typically the metal ion, must come first, people. If you put the negative ion first and the positive ion after, major violation, no credit. Okay, so we don't want to go there, yes? Okay, so the positive ion always come first when we're doing making our ionic compound formulas, right? So the lithium's just the one, goes to the fluorine, and the one from the fluorine goes to the lithium. So you switch to the other guy's subscript. The one from here goes to the subscript of F, the one from F goes to the subscript of Li. Students ask me, so you're switching the charges? No, we're not switching the charges. Lithium is still a positive ion, fluorine is still a negative ion. But the reason why we're switching the numbers, it helps us balance out the charge ratio, which we'll see in a second, okay? So when we put 1 there, and we'll switch the ones, we will get Li, all right? Li1, F1, okay? Li1, F1. Now in chemistry and in math, we really don't show the subscripts if they're ones, yes? So you will be left with simply LIF. LIF is your final answer and you're done, okay? So 1-to-1 ratio, notice that the charges are balanced, right? 1 positive to 1 negative, you're good to go. So we'll do some more. Okay, moving to calcium now. Calcium, we have what? Ca +2, we have F -1. What are we switching? Just the numbers, okay? So, the 2 from the calcium goes to the subscript of the fluorine. The 1 from the fluorine goes to the subscript of the calcium. So you're gonna get CaF2, right? Okay? You guys with me? CaF2, the 2 goes over there, the 1 goes over there. Now why is that CaF2? Calcium is a 2+ ion always, folks. And if you need to balance charges and calcium is a 2+ ion, you need 2 negatives and 2 positive, yes? But fluorine normally is only -1, yes? So what's 2 times -1? 2 times -1 is -2. So you got a +2 on this side, You got -2 on this side, because 2 times -1 is -2. Now your charges are balanced, so CaF2 is your final formula. Okay, so being able to crisscross properly, simple, but very, very, very important. Okay, because the funny thing is, now you know to write these formulas, right? Later on, when you do stoichiometry and something called GFM, they can ask you to write the formula or find the GFM. If you can't write the formula properly, you can't find the correct GFM. Once again, it gets worse, right? So no problem. Okay, so what we're gonna do now, we're gonna fill the rest in, right? I'm not gonna use crisscross because we got these two examples right here. I'm gonna fill these guys in, no problem, okay? Remember, just the numbers. In your subscripts, there should be no charges or anything. It's understood the first guy's positive and the second guy is negative, all right? So the third guy here is gonna be AL, right? F3. The 3 goes to the F, the 1 goes to the AL, bam, you're done. Over here, between the lithium and the sulfur, you will get Li, okay, 2S. The 1 goes to the S, the 2 goes to the Li, Li2S is your guy right there, okay? This guy right here would be Ca2S2, right? Now you might ask, do I leave it like that? Guess what you can do? Remember what we said, right? Simplest whole number ratio possible, yes? So these 2's will cancel each other out. Very important. The final answer, guys, will be CAS. Okay? So if you can reduce the subscripts, reduce them. Okay? No problem. So CAS is the final answer. Alrighty. So AL plus 3 and S minus 2 will give you AL2. The 2 goes to the AL. S3. Okay, bam, you're done, you're moving on. Over here is lithium and P minus 3. You will get Li3P, okay, no problem. Between Ca and P, you will get Ca3, the 3 goes to the Ca, and the P gets the 2 of the calcium, okay? Moving on. Al and P right here. Al is plus 3. P is minus 3. So you're going to get what? Al3P3, right? Do you leave it like that? No, you don't. You got to what? You got to reduce, you got to simplify, yes? So you're going to get what as a final answer? ALP, all right? ALP. That's not the name, by the way. All right, so moving on. Alrighty, so hopefully we see how the pattern here, right? We're just switching the numbers. And nowhere in the, when I switch, I have numbers and charges in the bottom right here, okay? It's understood the first guy's positive, the second guy is negative. All right, let's fill this last column out, and then we'll name them, and then we'll get out of here. Okay, so lithium and C, right, will be Li4C. The 1 from the lithium goes to the carbon, the 4 from the carbon goes to the lithium, Li4C. With this guy right here, it's Ca, right? Ca plus 2 and carbon minus 4. You will get C4, Ca4C2. The 2 from the calcium goes to the carbon. The 4 goes to the 2 from the calcium goes to the carbon. The 4 from the carbon goes to the calcium. Okay, it's like a tongue twister. So, do I leave it like that? No, you don't, okay? Gotta reduce, because 2 and 4 can reduce with each other, yes? So you're gonna get as the final answer, Ca2C. Okay? Alrighty, and the last crisscross we're gonna do, as you guys can see, is between Al plus 3 and C minus 4. It's gonna be Al4, alrighty, C3. Bam, and you're done, okay? So right there, we just did crisscross method for a number of guys right there for binary ionic compounds. Now let's gonna name some of these guys, okay? All right. So let's say you have LiF, right? Simple rule. The first guy, the positive ion, the metal ion stays as is. So you're gonna just write down lithium. Lithium, bam, as is, no problem. Right off the reference table. You're gonna table S, the periodic table, you're good to go, bam. Now, F, when it's in a compound form, okay, the negative monatomic ion gets an IDE ending. So you have to, instead of saying fluorine, it turns into fluoride, all right? So it's gonna be L-U-O-R-I-D-E, lithium fluoride, okay? Done, all right? I'm gonna do one of each, guys, for the sake of time, okay? For this guy over here, CAS, metal ion, name as is, you simply say calcium, right? Right, bad. The S, sulfur, will make the non-metal ion, will be sulfide, okay? Alrighty, so that's the only thing, the modification you have to make, folks, is with the monoatomic non-metal ion. Give it an IDE ending, okay? IDE suffix, no problem. Calcium sulfide, and you're done. Let's do this guy right here. Al and P, right? Al is the positive ion, monoatomic ion, positive, leave as is, all right? Aluminum.
Bam, done.
All right? For the P, he's a non-metal monoatomic ion. He gets a what? ID ending. So instead of saying phosphorus, you change that to phosphide, okay? And it just takes some practice, people, in terms of knowing the names. Don't get overwhelmed. Oh my gosh, there's so many different names. I can't remember them all. It takes practice, and over time, the names will stick on your fingertips. Phosphide, fluoride, oxide. You know, it'll be a breeze, okay? Alrighty. And the last one we can do is this guy up here, right? Let's do this guy up here, the Li4C, okay? How do you name Li? Lithium, it's a positive ion, so you don't do any type of modification or change. The C, what's the name of the C gonna be, do you think? Negative non-metal ion. Instead of saying carbon, you say carbide, and you're done. So this is lithium carbide. Bam, okay? And the others follow that same pattern, guys. So you can knock those out and for extra practice. All right, guys, as always, hard work but sacrifice equals success. Take care, study hard, be well, all right? Take care.